Welcome to the AMATIC 2015 webinar series. My name is John Oakes and I'm the Professional Development Coordinator for AMATIC. Today's presentation is Calculus Alive, Motivating Students with Applications and Flipping the Class for Active Learning with Shawna, Haider, and this presentation is sponsored by the Innovative Teaching and Learning Committee of AMATIC. And AMATIC is the American Mathematical Association of two-year colleges, and our core value is building expertise and exhibiting leadership in the teaching and learning of mathematics, enhancing personal growth, and improving teaching methods and effectiveness as a personally initiated lifelong responsibility. And more information can be found on our website at amatic.org. And please note that the views expressed by the presenter are not necessarily the views of AMATIC, and any commercial products mentioned by presenters are not endorsed by AMATIC. And WebAssign is proud to support the AMATIC webinar series. And so, as we are switching to the presenter slides today, I'm going to introduce Shawna real quickly. So, I think that you should be able to do that, Shawna. All right, so I see it coming up. So Shawna teaches at Salt Lake Community College and she loves her job. She has a master's degree in mathematics from the University of Utah, and for her thesis she worked with the engineers at the Utah Division of Air Quality to develop a model for air quality in future growth scenarios, and the modeling involved the differential equations, which she truly loves. So with that being said, let's welcome Shawna in the chat room, and I'll turn it over to you now.
Okay, just a sound check. Can you hear me okay?
I can hear you clearly.
Okay. Well, welcome everyone. I'm very excited to be here today to share with you some of the things that I've excited about that I've been working on for the last 2 or 3 years with calculus. And I see people from all over the US and Canada, and this is really exciting. So let's go ahead and jump in and get started. I wanted to try and make calculus come alive with real-life problems. I was working with our e-learning department to build an online calculus course, and we wanted to have the focus be real-life problems and then surround that with the calculus concepts that we wanted the students to learn. And, you know, we so often hear that when will I ever use this stuff? And so my goal was to show them how they will, and that's the focus kind of the course. And so the first thing that we did, I had some help from the e-learning department, and they actually went into all of our calculus classes and surveyed the students. And they actually had permission and pulled them out one by one, and they talked to them, and they were looking to find what their field of study or major was. They were also looking at various areas in the field that they're interested in, tried to find out why they were taking calculus, find out something about their hobbies and other interests, and then ask them if they had a dream project or something they were really looking forward to, what might it be? And they compiled all of this data for me. And then I started looking, brainstorming, trying to get ideas of real life problems that would key into these various interests and fields of study. And as you can imagine, the majority of these students were in STEM, a large portion in engineering. I was kind of surprised of how many were in some kind of medical or biology or biotech or those kinds of things. And then it kind of ran the gamut of some other things as well. And living in Utah, a lot of the hobbies and interests kind of tied into things that were around Utah. And so I determined I wanted to make these problems be kind of Utah-based, something that they could connect with, and possibly something that they might then in their, think I could use this or see this in my career. And so then I built these courses around these problem scenarios, and I mentioned many are Utah-based. And then the course starts with a problem in each of these areas with a problem presentation. Then the students do a problem analysis, and then they're presented the learning materials, and then finally they come back and they actually solve the problem. And when they first talked to me about doing this, they said, we'd love you to do a problem-based learning course. And there's various definitions of problem-based learning. And so I just want to clarify, I call this particular course I built a problem-motivated learning, because I don't want them to take the problem and go out and do research and figure out how to go about solving it and so forth. That'd be ideal if they had 3 years to take the course. So the idea is they're presented a problem, very vague, on purpose, not enough information, just a basic, here's what you'd want to do. And then they had to submit an analysis of the problem. And this is done in our learning management system. And they just brainstorm. I tell them no research involved, just use your head. What things do you know from the past? What kind of things do you think you might need to solve this? After they submit that analysis, it unlocks for them the learning materials, where they go in and they learn the content, the calculus content, the various things they would do. And I'll show you a little bit of this in a minute. But basically then they go back and solve the problem after they've done that. So they're not going to go out and research and solve the problem that way. They are going to think about what they might need, learn the calculus, and then come back and solve the problem. So I just going to run through very quickly some of the scenarios that we came up with, and anything that I show you today, I'm going to give you a link to my website where I have a lot more information. You can actually watch the problem presentation videos, any of these things. So if any of this catches your interest, I'm going to go through these quickly to just give you an idea of the things, and then more detail would be available. So basically in Utah we have public transit, we have a light rail system tracks, and we have a front runner commuter rail. And so I utilize this. As you know, in calculus we're talking about position, velocity, acceleration, and so forth. And so we used problems that used our local public transit system. We also have in Utah, just south of Salt Lake Community College, Utah Lake. And Utah Lake is noted for pollution and problems with the lake, with companies. And so we have a scenario where a company was caught putting pollution in the lake, and they had stopped, and the students analyze various things as this pollution dissipates, and they look at limits as time goes on and various things like that. Because of interest in looking at the hobby portion of this, we have a problem about a bungee jumper. And this bungee jumper, I had just visited Royal Gorge, which is actually in Colorado, but just an awesome place, and they've had bungee jumpers there, and it's pretty crazy. And so use that one in the scenario, and it models they need to end up taking derivatives to find velocities and things, and this basically would be an exponential multiplied by a trig function to modify or to model the bungee jumper. A lot of medical interest, and so you'll see in this we tried to hit a lot of different medical things. This particular one was they were in a rural hospital in Utah and had to make decisions about when they would life flight a patient versus use an ambulance. And there's, from the American Heart Association, actually an equation that sort of predicts success rate of intervention after heart attack based on time that has gone by. And so basically they're taking derivatives of quotients and things in order to solve that problem. Lots of students were interested in some kind of rock concert, so I kind of utilize that as they're looking at the decibels, and they're looking at logs, and they're seeing the rate of change as they move back. If they're buying concert tickets, what row they would be on, and then they actually get to look up what decibels would damage their hearing, and they discover within this problem that they really don't want to be on row 1 for 2 hours anyway. So kind of a fun one to utilize, again, some more of their interest. Due to the medical one, I've got a related rates ones where they're looking at angioplasty and inserting a stent, and how fast the rate could be of expanding the stent so that they don't cause dissection of the artery, as the rate of change is, would be too quick, and we have all the information on that, so makes for an interesting problem. We look at an amusement park roller coaster and do some analysis of this, and this is essentially when they're in the section on kind of curve sketching and those kinds of things. This actually goes back to the Royal Gorge, because there's an amusement park there, and the guy was making bungee jump claims that were not right, and so now they've been hired to analyze his roller coaster claims. So it makes it kind of interesting. Lots of students were interested in renewable energy sources and various things like that. And so there's a problem about wind energy, and I took the information from the now I'm blanking out on the official name, but it's basically the International Wind Energy Association. I think they call it the IWA. And I actually got their data and did some modeling of how they're predicting wind energy growth in various countries. And then the students use that and analyze that with some calculus to find various things. Um, the, as I was working on these in the newspaper, they talked about in eastern Utah how they had just released some more permits for natural gas drilling, and so there's a problem about a natural gas pipeline in the drilling, and they need to run this line, and they can go across private ground, but they've got to pay right-of-way fees. They can go around on BLM ground. It's cheaper but longer. They can drill through a mountain, but they got to worry about environmental impact and so forth. And bottom line, this is an optimization problem, and so they are applying that, and this is what we call our signature project. And this one, the students have to submit to their e-portfolio, and with a lot of different pieces to it. So it's kind of a good capstone. They have to do a lot of various calculus pieces in order to then complete a report to the CEO of their company of which route would be best, and analyzing various scenarios. And in that problem, I just sharing that a student made the comment about this project, but he said it was an interesting project to me because I'm actually somewhat familiar with the area in this fictional problem. And what I say we because I actually had our e-learning helping me brainstorm. I mean, I came up with the problems, but I had them kind of help me couch them in a way that maybe didn't sound like a story problem, but kind of got the interest of the students more. And what we tried to do was do that, get at things that students are familiar with so they connect with them. And then we put the disclaimers at the end. These are fictional, but they could be real. They're legitimate kinds of things. And so I thought that was interesting. The student made that comment. I was kind of stuck on trying to figure out what would be an interesting something of area between curves, and one of the instructional designers said, well, I just had to lay sod at my parents' house, and they have this goofy sidewalk that had this crazy curve, and we just went to Google Earth, and this is his parents' house. And so then we took this and then we overlaid it with some functions and so forth and had them compute the area. So made it kind of fun. Now, the stuff I just showed you was in our Calculus 1 course, and I built and did that, well received, students wanting more. So I then worked last year to add Calculus 2. I followed the same patterns and so forth, and so now we're into what in our college is the Calculus 2 content. The fuel tank, we have Hill Air Force Base in Utah, and we see fighter jets going over all the time, so this one is figuring out some volume of this fuel tank that's on the fighter wing. The WISE launch, Utah State University has a space dynamics lab that works regularly with students, and a lot of our students are interested in going there after they finish at our college. And so I used the WISE launch, which was that space dynamics lab up there in conjunction with NASA, launched this telescope, and they compute the work that was involved and some other things with calculus. And we did have a lot of hobbies of fishing. We got some great fishing here in Utah, so we looked at a fish harvesting problem at one of the rural areas in Utah. And we're famous for the O-ring disaster. I don't know if you're aware that Morton Thiokol is located in Utah, and they are the company that built the O-rings for the space shuttle, so been a lot of interest there. So students are now looking at a different polymer for building these O-rings, and they're going to figure out the volume involved in some various things, basically a torus, and some interesting things in that problem. And we've got a flu epidemic problem, and we kind of put this in before all the flu epidemic things hit, and it's been made interesting for students. We have a USTAR biotech company that works with students and researching, and so we look at bioavailability of a drug. And I'm just zipping through because I just want to give you an idea, and then I want to show you how this is encased in the course and how I utilize it. And we were looking to do a suspension bridge, because a lot of good things we can get, the lengths of the suspension cables and things. Well, there's no suspension bridges in Utah that aren't little minor things. So we're going to put the first one down in southern Utah in Ruby Canyon in this scenario. And we've got a dead body that we kind of had a little play on, on the Cupcake Wars, and so the dead body was found. His competitor kind of got him in the Cake Wars thing. We have a downtown Gallivan Center, it's called, where they have a lot of concerts, and so the student is a sound engineer, and they're looking at the microphone, which is a cardioid microphone, and its pattern, and they're doing some analysis of this. And we got to get skiing or snowboarding in Utah, and this involves parametric equations. And then we've got programming a computer. We actually, a number of our students are involved in some kind of computer science type thing, and this one involves Taylor polynomials and Taylor series. And so basically these courses are completely built then around this. So for example, when they go into the learning management system, this is the course menu. It's basically, there are 15 problems in Calculus 1, and everything works around these problems, and in Calc 2 there's 14 problems that cover these various things. So I just wanted to go through and show you how I've utilized this idea. So they all basically follow this pattern of the student is presented with the problem. Our e-learning built the videos for me after I wrote down, you know, what I wanted to include. They are all under 1 minute. They are all very vague on purpose. Now, I don't think with our setup you're going to be hearing the sound, but I did want to let you see the video. This is the one for the tank. And he's basically saying that Hill Air Force Base is the home of the 388th Fighter Wing, and they have these fighter jets, and Lockheed Martin, who is in Utah, has been contracted to design a new fighter jet, and you're an engineer for an engineering firm that this Lockheed Martin is contracted with. And so they're designing the new jet, and it will have external fuel tanks on the wings, and these students need to figure out the volume, what they're going to hold, and later they go back and they figure out the surface area. So they're very short, very vague. The student then is supposed to brainstorm and essentially say what kinds of information would they need to gather. Because I try and tell them, if you're working in a job and you're this engineer, you're not going to have everything given you, boom, here it is. You have to say, well, I need to know the length of the tank. I need to know, you know, whatever kinds of things. And so they analyze and submit that, and they are emphasized that it's not a large time-consuming thing. It's to get them to do some thinking, not some Googling. Then they then get a problem response. And in this response, this is something that I made. And so I'm telling them some of the things that they would need to know. And I'm just, time out, I'm going to turn this volume down a little bit there. Okay, I just wanted to make sure everybody could still hear me, because that went a little bit interesting on me. So bottom line, they then get the information that they might need to solve the problem or kind of catch their interest. Can you still hear me? Oh, thank you, Julie. So they see the shape of the tank, and in that I'm explaining or talking to them a little more about what they might need to do this. And so I'm going to talk to them about how they could impose a function over the tank. You're not getting the sound, so I'm kind of the narrator here because it didn't come through. But after I explain that and how we could figure out a function, let me just kind of speed this up. So I'm talking to them about how they may go about solving this, and we talk about slicing and letting them see what's going on. So in this, I'm explaining what they're seeing here about slicing it, and I'm explaining to them. I'm going to fast forward a little bit, but I'm showing them the kind of thing we're doing. So sounds better if you're hearing how I actually narrated the real one, but I'm trying to kind of help you see. But basically in that, I give them the sort of the interesting of where we're headed, what kind of calculus we're going to learn so we could do that. And so these are usually very short as well, but giving them some information. So what did I use to put the function over the diagram? I just built that. I actually use WinPlot. WinPlot is free and I like it. I build things in there and then I just simply took the picture out of WinPlot and pasted it. This is a PowerPoint. And so I had the diagram in PowerPoint and then I just brought in that WinPlot graph. So okay, so then after the students are asked these analysis questions, and they may vary, but just ask them to think about it and they submit this, then they actually get to the learning materials. So they will then find in our learning management system after that, they get content videos, example videos, and then sometimes other resources that will help them learn the concepts they need before they go back to solve the problem. And I just wanted to talk for just a minute about videos because I learned a lot of things as I've done tons of videos over my career, and in working on this course I actually polled my students and I asked them some questions about what they think makes a good video and what kinds of things they're looking for. And the content videos and the example videos are two complete things, different things. I see Kevin said hello. Are you still hearing me okay? Just wanted to make sure we're still good. And someone let me know if we got sound still. Okay, great. So the content videos are much more structured. I typically do a PowerPoint first. A lot of times I try and do some interactive things embedded in it, and I would hit the content, like the concepts. Then the example videos follow, and these are much like I would do in class. After we learn the basic concepts, we work some examples of how to apply the concepts to problems. So these example videos are written with my tablet and recorded, just much like I would work an example on the board. And students came back loud and clear. They like that distinction. They like getting the content, but they love seeing, and they need to see, the handwritten, how you go about drawing a graph and doing it step by step. I asked the students what makes a good video, and I just wanted to share a few student comments. I don't want to sit through a 25-minute video. I know many topics require a lot more time to cover, so my advice is break it up. 3 10-minute videos, much easier to get through in an hour. Now this worries me because this was a math student. 3 10-minute videos, easier to get through than one that goes for an hour. But the big idea is break it up. And that's exactly what I did. I mean, if I'm trying to make a 10-minute video and it's a calculus topic that's a lot more involved than that, then I would make 2 videos or 3 videos and, you know, call them whatever based on how I broke them up. And students said they will watch 3 10-minute ones, but they won't watch I'll fix this 30-minute one. So that was one thing I got loud and clear when I surveyed the students. And the students basically say if they're too long, they skip them. They just try and get pieces out of them. They won't sit down if they think they got to commit to 20, 30 minutes. So I really tried to hold to the 10-minute time frame whenever I made these. You'll see on some I fudged a little bit. Some might be 11:39 or whatever. I think the max I might have a 15-minute one in there because it just didn't break up nicely. But tried in general to hold to that rule to keep student interest. As I went through the content, I'm just showing you an idea of when I did the content videos. They're much more formally presented like this. I had prepared stuff ahead of time, and then I go through and I narrate as I'm explaining here, you know, how to partition and then how to look at a piece of this curve. And, you know, I would be narrating, explaining the steps, but these are officially presented versus handwritten, kind of in the context piece of it, and well planned out to cover as quickly as I can, but as efficiently and not skipping any of the math kinds of things. So I try to make them very visual as I go, and try and utilize the fact that I am doing this on a computer. I can put some motion in there. I can help them see what they're doing along the way because I'm not relegated to a whiteboard. You know, I can bring in the pieces and explain as I'm doing that. So let me just kind of zip through that. But just saying that, it's easy as you're explaining things in a video like this to put motion. You know, graphing the polar, you know, as I'm explaining steps to go, I can show them and let them see the pieces as I'm going. So this just gives you a flavor for the type of things that I would put into a content video as I'm explaining the steps for solving. So these are, like I said, much more formally presented. Okay, so then after the content videos, I heard loud and clear from the students that they want to see writing on the screen and they want to see the steps, but they also don't like it if they're seeing their hand or they're seeing the whole head. They just want to see the math, but they want to see it step by step. They don't want to see just a shot of it all done. They want to see it as it goes. And I just picked a couple of student comments in this area, but loud and clear, I got a lot of student comments in this area. And so typically the example videos, and you aren't going to get the sound again, and that's fine, but I do typeset a problem, but then I work through it and I let them see the steps, and it's just as sloppy as if I would have done it on the whiteboard and didn't plan my space that well or whatever. So you get the idea. But so all example videos are of this type. They see just how someone would work the problem if it's not some gloriously typeset kind of thing. Just another student comment. The students in general, I think seeing those problems, I heard a lot of when I had surveyed them that they felt like the problems were effective in teaching them, and they did serve a purpose of helping them see a connection and why they would be learning. And so then, after I dealt with this and I got this online calculus class running with all these great problems, I started looking at my live calculus class. And this isn't a picture of them, thank goodness, but I was thinking about, I lectured. All as I did in calculus, and I mean, I'll say I think I did a pretty good lecture. I, use PowerPoints, I use active things in my lecture, but I lectured. And so I started looking to see how I could do more active learning instead of passive learning, because I was up there teaching and I thought I did a great job teaching, but are they learning? Are they out there getting what I'm throwing out there at them? So I kind of reflected on the teaching and learning idea, and we've heard a ton of things about active learning, and I know active learning is a great way to go. But as I saw this cartoon, I'd kindly relate, because it says, you're the new hire, welcome aboard. Here's our prepackaged curriculum. If time permits, encourage critical thinking. And that was my big problem. There's all these things I would love to do in a calculus class, but I don't have time. I have so much to cover, and our calculus classes are so prescribed of you've got to cover all of this, because of course that feeds this next class, and we see that in math all the time, and that feeds this next class. And so I just felt so I can't give up the lecture because I got to get all this stuff covered, and if I let them be more involved, it takes more time, and I don't have more time. And so I had kind of struggled with that. And then I went from this scenario and decided I'm ready to flip my classroom. And so I utilized all of the work I had done in my online course, and the reason I'm sharing this part with you is if you want to do online or you want to flip or you want to do both, they can go hand in hand. So I already had all these videos created. I didn't have to create any more. If you wanted to do something like this and say, I don't have time right now to create all the videos, I got all my videos out there if you like them. And as you know, there are tons of wonderful videos out there now. A few years ago, I think it was, a little iffy, but there are so many great resources. If you decide you want to try and flip and you don't have time to do the videos, or you want to work on them over time to maybe personalize some of yours, there's lots of good resources. This is a picture of a couple of my calculus students, and they're actually doing a little antiderivative game, and it's kind of fun to get them thinking about, first they take, it's when we're first introducing antiderivatives, and first they take derivatives and then they flip it over and get it set to do the other side, and they go backwards, and this is before they've thought of the idea of an antiderivative. We just introduce it here, and then we have them play this game, and they're trying to get things in a row, but they're, they have to be able to do the antiderivative and so forth. And so they have fun interacting with each other, but yet they are learning the ideas. So I totally changed my class from me up there lecturing to the students talking with each other, and it's made a huge difference. Wanted to share sort of the setup of that a little bit. So basically I have it devised by weeks, and I just have this in the learning management system. They have some concept videos that they watch before class, and these are those 10-minute pieces of things that give them the main concept. I usually don't present them the example videos because a lot of times we'll be doing things like that in class, just depends on the topic. I also utilize My Open Math questions, and My Open Math is a free open educational resource, and I embed it in learning management system, and I make them do it before they come to class. There's usually maybe 3 to 5 questions, and they're on the algebra and trig skills that they'll need for our calculus topic for the day. A copy of the learning material and games, Alexis asks, and the answer to that is yes. At the end, I've got a link to my e-portfolio where I put a link to what I'm sharing with you right here today, plus my calculus videos and another few things. That game you saw, I utilized from Maria Anderson. She has Busyness Girl site where that's where the game was, and I will put a link to that. So I'm happy to share anything and everything, because a lot of what I have I've gotten from other people willing to share. So thanks for asking, and I'll have that information at the end. So anyway, you know, one of my biggest complaints, and probably you guys too, in calculus, you can get them the calculus topic and they learn the calculus topic, but they can't get the problem right because they mess up the algebra and the trig. And so I make them have a little refresher before they come to class. They have to watch these concept videos and they have to do a little brush up in My Open Math. So free resource, and I'm going to show you what it looks like in a minute. Then they come to class and they do activities for discovery or reinforcement, make some connections with the concepts that I would have not had time to in a lecture. And I use some OER materials for some of my class materials, and a lot of them I've pulled from what's called Active Calculus, and I will share that link with you as well. That's another open educational resource. Plus, I've designed a lot of my own. We also we have some really quite challenging homework problems in our book, and typically it was teach the main stuff in class, they go home to do the homework, and they can do the easy ones and they get stuck on those really hard ones, and there's some great things to talk about in those hard ones, but who has time to do that? So now we do. And I'm also, so they can come to class, and sometimes I might say, has anybody done this homework problem? They'll all be like, and so then we talk about it in class, or I have them each do a piece of it or whatever. So I have time to do those things that I wish I used to do. I also incorporated in this class weekly reflections. We have sort of a push to have them involve some writing across the curriculum kinds of things, but also sort of a push to have them reflect on learning. And so I figured that's a great thing to incorporate. This, I'll kind of share with you what I do with that as well. So class time discussions, discovery, working of some of the harder problems. Sometimes I'll have them do an activity that's sort of a pre-activity. They haven't the concept yet and it lays the groundwork for it. Or sometimes I'll do an activity, they learn the concept and now they're either going to expand or they're going to reinforce or they're going to make a graphical connection with it. I have totally loved the student interaction and learning and the sharing and the teaching that goes on from student to student. And I knew this could be great, but I had a lot of trouble because I thought I'm a good, efficient lecturer. I can cover all this stuff. I can make it interesting. I can cram it down their throat. But this way, they get the main thing before they come and they have time to work with each other and take a little time. And there is nothing better than a student explaining to another student something that the one student's confused on, and they both really get it when they're done. And I've just totally loved that. I know this is small, but I just took a little screenshot out of the learning management system of kind of a sample week. So you can see, basically, first of all, we got big budget cuts. They gave us no copy budget whatsoever. So the students print out the activities for the week, and I have them posted in there, and they bring them to class with them so that we work on different pieces of them during the week. So there's their activities for the week. And then before class on Monday, Tuesday, Wednesday, I have, you know, depending on what we're doing, and Thursday, I have these videos for them to watch. You can see on Monday there was 1 video. On Tuesday there was 2 because it would have been too long, but they'll watch 2 short videos. So on Wednesday, they watched a video on direction fields and they completed MOM. MOM stands for My Open Math. And it was on DE, differential equation preparation. And I'll show you a couple of samples of those kinds of questions. And then I will often include other things, like here they were doing slope fields. So I gave them a link to a slope field generators, a couple different ones, and told them to go play with them. And then you see they end the week with some kind of a reflection. It's just in the learning management system. they type a paragraph answering whatever question I ask them. And I'm going to share that, some samples with you as well. So basically, that was just a little closer view. So my open math, like I said, this one, it looks like I had 6 questions, but the idea is it will plug into just about all of the learning management systems now, and we were going to be doing derivatives of inverse trig functions and working with inverse trig functions in calculus. How many of them, they just kind of, it's inverse tangent, and they just are rusty on it. And so these questions, there was 6 questions that kind of reviewed for them some things about trig and about inverse trig functions. Just a couple other samples. When we were going to be working with the logs, I just put some questions in to let them get work thinking about logs again, and what did a log mean and how to work it. So these are all from pre-calculus and from various college algebra or trig type topics. Here we're going to be working with exponentials and logs, so I wanted them to review some things about their graphs, some properties of the functions, something about their domains, their ranges, and so forth. And so I incorporated 5 questions about exponentials and logs. On this one, we were going to be doing these volumes of revolution. So we're going to be doing washer method and shell method. And so I have a thing that reviews with them geometry of circles, so they can think, what's the area of a circle? How do I find this? And so I just typically pick topics that I see students mess up in calculus and put them some questions. Okay, so I just wanted to briefly give you an idea of some of the things we do for our class activities. And I know this can be small again. I have links to all of these at my in my e-portfolio that I'm going to share with you at the end. So basically, something that looks like this one, I took it out of that active calculus, it's called, and I'll give you that link in just 1 minute. But they have a lot of preview activities, and this one is going to be leading them towards going backwards, thinking of the antiderivative. They have the velocity and they want to get position, but they haven't thought about that yet. And so this actually walks them through some questions where they think about that. And then when we can talk about it, then they're like, okay, that it's just an antiderivative. So it's kind of an interesting way to introduce that. So as I was telling you, I actually attended a workshop. These guys are out of Michigan, Grand Valley State, and they have this active calculus, they call it. And they have this open calculus site, and I put the link right there, and this will all be available after as well, so you don't need to write it down unless you want to or whatever. But he shares so many good things here, but basically he's built a whole calculus course on sort of a discovery learning, kind of actively involved doing activities versus lecturing. And so I've got a lot of good material from there, and that's the beauty of open educational resources. You can go in and pick and choose what you'd like. You can also edit. Sometimes I'll find one and I'll really like it, but I just didn't like one little thing they did. Well, I can go in and I can change that. So it's pretty awesome. Some of them I have built myself. This one they were going to be doing trig sub. So before they start doing the trig substitution, I make them do the fundamental identity. I make them think about different connections with it. It's all trig stuff at first, but they don't remember it, or they don't get it, or they didn't get it the first time, or they're just a little rusty on it. And so by doing that first in an activity before we even introduce the trig substitution process, they've got all of that fresh on their mind. I was just sharing with you, I told you that whoops, let me go back, it flipped. So I took a lot of the problems that I had built for the problem motivated learning class then, and I bring them in here as an activity. So this was that laying sod one that I told you about, and then I put them to work, and they're in groups and they're talking about how would they go about doing this. And so then they have the different information for the curves, and they compute the area between the curves. So just was going to show you a flavor of most of these activities. This one's out of the active calculus again. A lot of them have a lot of good geometric connections, graphical connections. So I really like those. I just pulled a few of them that I like. This one basically, they they're going to sketch the graph of the derivative and the second derivative. And this is before they've learned a lot about curve sketching things. They just know that the derivative means the slope of the tangent to the curve at a given point. And then they sketch the two graphs, the derivative and the second derivative. And then there's a bunch of questions after that have them make those connections. Oh, when the first derivative is positive, this function is increasing. Oh, look at the concavity and look at your graph of the second derivative. And they make those connections by doing this activity. So I think you get the idea on that. Now, the last piece of this that I wanted to show you was that reflection on learning. And so just within the learning management system at the end of the week, I asked them some question, and it ties in with something we were doing for the week. And it gets them kind of reflecting, thinking, and answering questions. One question I asked them at week 5 is about the flipped classroom. And I basically explained, this is the flipped classroom, this is it, you didn't know you were getting it, but what do you think? And I just wanted to share a few things. Students like having videos to refer to later as well as earlier. They'll say they'll watch it and then they like to go home and refer to it again. And this one, it says, last semester I never took notes because the teacher explained things too fast anyways. That was probably me when I used to lecture. So I like working in groups and doing the in-class activities as a whole class as well, because we do some of both, or we'll then come together and kind of put the concepts together as a whole class. And I like this last sentence, it keeps me paying attention. So I really do think when the students are actively involved, you know, they're not just sitting in your class, they're sitting in your class thinking about what you're talking about. So I just wanted to share a couple other comments here. An advantage, I'm not fretting about copying down formulas and proofs during class because it's easy to miss a negative sign or forget a parentheses. And so he likes the idea you can pause the videos, write things neatly down, and then continue. Couldn't do that in class as I was taking off. I didn't try and bias these students, and I have maybe one a semester that kind of had some issues, but most of them the first week kind of like I'm not sure, and by week 3 they love it. So they have learned how to utilize it to their advantage, and most of them actually want more of that. I think one last one, I'd ask them what are the advantages and what are the disadvantages of teaching class this way. So in his response to the disadvantages, he says he hasn't noticed it. Technically, it lengthens the hours required for the course. I think what he's saying is I have to take time out of class to watch these videos first, but I would likely be spending that much time interpreting sloppy notes, diagnosing incorrect formulas, and I think struggling on homework without enough, you know, base to do them well, because they do say it does save them time on their homework because they're not spending a lot of time in that let me still figure it out phase. So if they start giving me, oh, this is too much time, I have them compare those things, and I think they soon realize it's actually saving them time in the end. It's just different, so the idea for them is a little different. I didn't know if I'd have a lot of time at the end, so I actually encourage my students, if they find anything on the internet that's funny that ties in with what we're doing, to share it. And so I just threw a couple of those in at the end since you've been good to sit with me. So how good is this, though? The student finds this and posts it as we talked about the intermediate value theorem. And I can explain the intermediate value theorem all day, but just seeing that illustration, how are you going to get from one to the other without crossing the road? So they can be pretty effective. I'll just real quickly show you the derivative of Optimus is Optimus prime. And you've probably all seen this one because it's going around. But students love to share these kinds of things once they've been involved. I hadn't seen this one before. If this is the mean value theorem, then this is the good-natured value theorem right there. But again, as they're sharing these things, though, they're helping each other. They'll probably remember the mean value theorem after seeing that. And then this one, they all love it when you talk about jerk, when you say the third derivative is jerk. So they want to throw that in there. So anyway, I just talked as fast as I could because I had a lot of stuff I'm excited about that I wanted to share with you. So I'd like to open it up for any questions, and let me just tell you a couple of things quickly before I do. This first link is to, they are taking away, whoops, didn't mean to leave. They're taking away my website at the college. They are no longer going to provide server space for individual faculty pages in our budget cuts, and so I'm in the process of converting things over to this jimdo.com, which is basically, we have to do an e-portfolio. So I have this info there, and I'm happy to share any of that. The second one, of course, my email address. One of the reasons I do things like I'm doing today is to build a network of like-minded people, and I love sharing things. I love helping people. I love getting their ideas. So I'd be totally delighted to get emails from anyone. I do want to, I thought I had this as a link, but apparently not. I do want to just go for 1 minute and then think of your questions to that site so that I can show you where you could access the material. So let me just go there. Whoops, let's see if we can get there. Okay, so when you go to shawnahaider.jimdo, it's jimdo.com, my e-portfolio is here, and if you just scroll down, I just put this link, so on the home page, recent presentation information. And so this is where I'll have the links to everything, and I did a presentation last week that's there, and then the one today is right here. So I have links to any videos that I've made for the classes, info about the problem-motivated calculus, including you can actually watch all those little videos, those less than 1 minute videos of the scenarios. And yeah, maybe you don't have Ruby Canyon in your state, but you've probably got somewhere you could build a suspension bridge, etc. And so, you know, I think any of these could maybe give you ideas or apply. I have links to the flipped classroom active calculus information, which will have links to the active calculus site, links to all of the activities that I have used, so all of that info is there. And then I have the link to the PowerPoint presentation that I used. And I'm going to add another one because Alexis asked. I'll put a link to Maria's site where I stole some calculus games. So, okay. Yes. So thanks, Julie, for putting that in there since I took off. So appreciate you guys kind of watching out for each other. So, well, thank you. I had to do a post-tenure review this year. We have to do that every 3 years, and we're required to have an e-portfolio. So there it goes. But anyway, questions, anyone? Did I miss any questions, John, as I was talking? I'm kind of looking here. Julie is so on the ball. So there's the link to Maria's site, and it's busynessgirl.com. And if you just went there and did a search for derivative game, it would be there. She's got a lot of great resources. Okay, so when do the students do their homework? Okay, so basically, they watch this 10-minute video before class, sometimes 2 10-minute videos, and they do a few little questions. And then they come to class and we talk about, and we're involved in these, and then they go home and they do their homework. And right now, I typically require pretty much the same thing as I would require, you know, as those that are not doing this, that are doing the lecture, would require. So we have an adopted calculus book that's departmental wide we use, and we have a required departmental final. So they still need to do those homework problems, and I often will trim them down a little bit as far as the number of repetitious ones, because they've actually got more hands-on things in class and maybe not need to do quite as many, but they do their homework problems after class just like the student not in this model would do. Okay, we're currently using Stewart for our textbook. So it's, like I said, it's a departmental wide adoption. So, but I built all of this to plug into whatever we're using. I made the mistake, I used to build online classes sort of around the book we were using. Now I build them completely objective and topic oriented, including the activities, and then I can just plug them into whatever book we got. So. Okay, how do you hold the students accountable for watching videos in prep for the next? I was really worried about that before I started this, because I thought, how am I going to make them do it? Should I embed things in the videos and da-da-da-da? And I didn't do that. I just said, you need to do this or you're going to be messed up in class because you won't know what's going on. And I've gotten feedback from students saying that very thing, you know, saying, I've been watching the videos really good, and last night I was tired and I didn't do it, and holy cow, I didn't like class today because everybody else knew what was going on and I didn't. So I think that at the calculus level, you almost don't necessarily need to motivate them. They find if they've watched it, they totally are clicking with what's going on in class, and if they haven't, they don't like the feeling and they don't do it again. I haven't found it to be an issue. I don't give them points for it. I don't police it at all. But when they're in class, if they haven't done it and they're trying to do what's going on, they don't like that feeling of, I don't know what you guys are talking about. So I think if it were an intermediate algebra, and I've done some flipped with that, I've had to do little, I call them readiness quizzes that they have to take after they watch the video, and they're worth points to give them incentive to watch the video. So I think part of it depends on the maturity of the student, and calculus students, it hasn't been an issue. So they are doing regular homework and watching videos for the next class. They are, yes. And like I said, the videos that they watch, 10 minutes, maybe 20 if there's 2 of them. I'm not talking about they're watching an hour or 2 besides doing their homework. So yes, they typically tell me they go home and they work on the, well, I don't know if they're home, wherever, and they work on their homework problems. And then some of them, depends on what time I have the class. Sometimes they watch the video before they come to class the next morning, you know, so it just depends. Oh, John, he tells the students to go home if they haven't watched the videos. And I think once a student gets used to the idea of the flipped classroom and they see the benefits of it, that it's a motivator in itself too. I want to be prepared because then I'm going to be able to really get this stuff. But I do think that the lower level students, you know, have to have some kind of policing factor. Software to produce the videos, I use Camtasia. And I love it. So I have a tablet PC, so when I work the problems, I can just, you know, write right on the computer screen. I had just like a Dell tablet PC. I now just got me a Surface, and they work great for that. Camtasia is a great product for making all kinds of videos. Yeah, and Julie, I totally agree with you. If they've not done a flipped classroom, they kind of come in there and go, huh, I have to do something before class. And after they get in the routine, it works really well. So, yep. Okay, any other questions? I've enjoyed having everybody hang in here and let me share all this stuff I'm excited about. And I really hope to hear from a lot of you. That's why I gave you that. In fact, I'm going to go back to well, if I can find it, contact info, because if you know, would love to share with me some things, whoops, where'd it go? I want at the end. If you would love to share any things you're doing or just have additional questions later, please contact me. Like I said, that's my motivation for doing this. So you're welcome, Kevin, and thanks everybody for coming.
Well, can we all thank Shawna again in the chat room? I enjoyed the presentation. I hope that all of you did as well. So thank you, Shawna.
Yes.
I am going to hide your info at the moment so that we can go to the conclusion slide. So thanks to all of you for participating in today's AMATIC webinar. And if you'd like to support future AMATIC webinars, please consider becoming a member of AMATIC at bit.ly/join-AMATIC. And please remember to like us on Facebook at facebook.com/AMATIC. And recordings of past AMATIC webinars can be found at bit.ly/AMATIC-webinars, and it typically takes us 1 to 2 weeks to produce and upload webinars to this archive, so today's webinar will be there as well. And if you could please take 2 minutes to evaluate the webinar content and the presenter today at bit.ly/AMATIC36, that would be great. You can actually click right on that link so that you don't have to type it in. And if you need email confirmation of your participation in this webinar, please fill in the optional section at the end of the evaluation. And if you have any special request for your webinar certificate, such as something for your state, professional development requirements, put it in that box as well, and I'll make sure to get you taken care of. So again, please take a few minutes to complete the evaluation, and if you haven't thanked Shawna in the chat room already, that would be great. So thanks again to everyone. I'm going to end the recording right now.